Hi, everyone, and welcome to another of Ian's interviews. Today, I'm interviewing the CEO of Mobileye. Mobileye is a company involved in assisted driving and autonomous vehicles, and Professor Amnon Shashua is leading up the company. What's your minimum specification? Well, shucks, the cloud is here, but which cloud do you trust? Manage your infrastructure with Linode, the biggest independent cloud services provider. Linode offers double the database performance per dollar than the Big Four, and now enhances it further with new NVMe-backed block storage. Spin up a game server, website, personal VPN, or something more bespoke today with a free $100 60-day credit at linode.com/TechTechPotato. So Mobileye was founded in 1999, it IPO'd on the New York Stock Exchange 2014, and was acquired by Intel for $15.3 billion in 2017. Now, Professor Shashua he's still an academic. He holds the Sachs Chair of Computer Science at the Hebrew University in Jerusalem. He's co-founded multiple companies inside the machine learning space, and is even involved in the first bank to be launched in Israel in 40 years. It's a digital bank and uses lots of machine learning. But the focus today in this interview is Mobileye's CES announcements, and in particular, a brand new chip for Level 4 autonomous vehicles. For people who haven't necessarily heard of Mobileye before, can you kind of put the company into context of where it sits today?
We are in the field, so we are in the automotive field. We are, one of the biggest providers of driving assist technologies using computer vision. So we have a family of system on chips called EyeQ that process front-facing cameras that power, a wide spectrum of driving assist customer functions. We have shipped 100 million chips to date. We are on the road for 22 years. We work with almost all the major and non-major car makers, and we are also working towards autonomous driving. So the entire spectrum from driving assist, premium driving assist, level 3, level 4, computer vision, driving policy, mapping, all the components that you need in order to build an autonomous car. And in the meantime, we're also supplying to the car industry the technology for powering driving assist today.
So, as I've covered Mobileye over the years, one of your key points is in this high performance, low power silicon design paired with your computer vision autonomous driving algorithms. And this week at CES, you're announcing the EyeQ Ultra. Um, would you like to go into what EyeQ Ultra is? Because there are some mind-boggling numbers involved in what you
Yeah.
guys are announcing.
So when you build a business, it's all about cost performance metrics. So it's not enough to have very, very good performance. You have to have also very, very good cost if you want to build a viable and sustainable business. And then this is what Mobileye has done over the years. Today on the road is our 5th generation SoC called EyeQ 5. And these SoCs are based on a number of proprietary accelerators. So it's not only that you have CPUs, but you have also accelerators of a wide spectrum of workloads. So this is not only deep learning compute, it is also multi-threaded compute cores that are similar to FPGA. Cores that are SIMD, VLIW, very long instruction words, a kind of a variety or diversity of accelerator cores that Mobileye over the past 16 years have been developing and launching. As today, there's the EyeQ 5, and we are announcing at the CES the EyeQ 6, which comes in 2 varieties, and the EyeQ Ultra. If we go directly to the EyeQ Ultra is an AV on chip, autonomous vehicle on chip. It has, in terms of some details, it has 64 accelerator cores, which are divided into 4 family of cores. We have one family which is purely deep learning compute. We have another family which is CGRA, a coarse-grained configurable array, which is similar to FPGA. We have another family of multi-threaded, which is SIMD VLIW. We have another family which is barrel-threaded CPUs. So altogether, there are 64 accelerator cores, 12 RISC-V CPU cores, each is 24 threads. We have a GPU and an ISP by ARM. It's a 5 nanometer process. First silicon is going to come out end of fourth quarter of 2023, so 2 years from now. Normally in the cycle of from engineering sample to start of production, in all our the families of SoC so far, we start with a cut 1, which is the first engineering sample. Then half a year later comes a cut 2. And then there is a PPAP process, which is very, very, very critical for making the SoC automotive grade, which takes somewhere between half a year to a year, and then it's ready for start of production. So 2024, we can have vehicles with EyeQ Ultra on the road, but in terms of mass volume start of production, automotive grade, it's going to be 2025.
The way you're talking about it very much sounds like a monolithic piece of silicon, and I'm right in saying that, aren't I?
Yeah, it's a one piece, it's one package, one monolithic piece of silicon, yes.
A lot of times when we talk about silicon in autonomous driving and vehicles, there have to be backups. So would an EyeQ Ultra solution have 2 chips for redundancy, or are you trying to plan redundancy just on the single chip? Have the rules about what customers need regarding redundancy in that respect changed over the years?
So we're working at a system level redundancy in many, many aspects. So one level of system redundancy is about sensing modalities. And we're working end to end using only cameras, and then end to end using only radars and lidars. So in terms of the sensing state, the perception of perceiving the world is done through 2 parallel streams which do not talk to each other. The cameras do not talk with the radars and lidars, and radars and lidars do not talk with the cameras. And this gives us a system level redundancy. We call that true redundancy. At the chip level, the 64 accelerator cores are divided into 2 pieces of 32 cores, creating internal redundancy. There is an MCU, an ASIL-D MCU outside of the EyeQ Ultra, such that with the dual ASIL-B plus a ASIL-D MCU, we get an ASIL-D system. In addition, and that's a product level, there is a fail operation where we take an EyeQ6 low. An EyeQ6 low is a very, very small chip. It's about a 5 tops silicon. It's very, very cost efficient, and that processes a number of cameras for a fail operation stream, a completely fail operation stream, such that if something goes wrong, the car can go into a safe state and stop on the side.
When we see companies like yourselves talking about autonomous driving or level 4 autonomous driving with regards to the EyeQ Ultra, they have multiple chips in play, multiple silicon pieces, whether it's multiple CPUs or multiple GPUs. Yours is designed to be that all-in-one solution. There's no other silicon compute resources in play unless it's for redundancy or failover.
Okay, so we have gone through an evolution. So today we have a system on the road, which is just camera-based. It's not level 4, it's called the level 2 plus. It has the first launch is in China with a Geely brand called Zeekr. It's 11 cameras around the car, full 360, 2 EyeQ5 chips. An EyeQ5 is about a 15 tops tera operations, DL tera operations per second. So it has 2 such chips, and it provides an end-to-end capability. So we have unedited videos on the internet showing how this car drives in multiple sites in Tel Aviv, Jerusalem, Munich, Tokyo, Paris. I'm going to show it at the CES. also in China, in Detroit. So it's really end to end, but it doesn't have the robustness, the mean time between failure, the level of robustness, which is good enough to remove the driver out of the loop. For that, you need more compute and more sensor modalities in order to create redundancy. These are the LiDARs and radar. So now we have another system. It's also going to go into production early 2024. It's going to have a level 4 capability. It's also with the Zeekr. It's going to be based on 6 EyeQ5 chips. Right? So it will have level 4 capability with a certain limitation of ODD, operational design domain. We have on our robo-taxi an ECU called AV-Kit58. These are 8 EyeQ5 chips. And this is powering our robo-taxi, which has been debuted at the IAA in Munich back in September, and it's going to be on the road middle 2022, homologated by the end of 2022 in terms of the hardware to get all the permits to remove the driver from the road. The EyeQ Ultra is learnings from all this evolution. So with EyeQ Ultra, after building the AV capability, and we built an end-to-end. It's not only the perception, it's a driving policy, the control, and you can see that from all those clips on the internet. We came to the conclusion of what exactly the compute need that we must have in order to support a full level 4 with an MTBF high enough to remove the driver from the loop. And we came to the conclusion that it is 10 times EyeQ5. So EyeQ Ultra is roughly a 10 times EyeQ5 single chip. Now, why single chip? Because at the end of the day, cost matters a lot. Cost matters a lot if you want to be an actor in what will evolve to a consumer AV. It's around 2025. So that there's robo-taxi and then there's consumer AV. Consumer AV means you buy a car, you pay somewhere around $10,000, and you get an option by press of the button, the car becomes level 4. So you can have minds off, eyes off. We don't need even to sit behind this on the driver seat. And so the cost here matters a lot. And then ECU with an EyeQ Ultra will be the cost of that will be significantly less than $1,000. So the way we designed it is that a full level 4 system, the cost, sensors, compute, everything in terms of cost will be significantly less than $5,000. That will enable an MSRP to the customer for around $10,000. And that's around 2025. So this is why it's very, very important to get this monolithic, an AV on chip, given all the learnings that we have done, all the evolution of multiple chips, in order to understand exactly what we need in order to support a level 4 product.
It's almost crazy to think that the major cost in design in autonomous vehicle systems in the future is going to be the sensors and not the silicon. That's how it sounds, how you've just described it to me.
So with sensors, there's also some breakthroughs. So there are 2 types of sensors that the public are aware of, which are cameras and LiDARs. With LiDARs, there's a certain cost that is inherent. It will not go down to the cost of a camera, and it will not go down to a cost of a radar. And then we're developing the next generation LiDAR. It's a frequency modulation coherent wave. It's called FMCW LiDAR. I talked about it at last CES. But the real breakthrough, in my mind, will come from the next generation radars. And I'll show at the CES. I talked about it at last CES, but I'll show a project that we are building. It's called a software-defined imaging radar. It has more than 2,000 virtual channels, but there are many other, important spec elements, not only the number of virtual channels, that enables us to develop software running on the radar output that mimics. It's so high resolution. Whatever we do with cameras today, we can do with this radar. So we can treat this radar as a standalone sensor. in terms of building a sensing state, building a perceiving the world around you. So you can look at a very congested traffic with lots and lots of pedestrians and vehicles. Today, radars have no chance in kind of separating the different objects, stationary and moving, and pedestrians, and you can have a pedestrian near a vehicle under a bridge, all sorts of distractions that could happen that radars today cannot handle it. This type of radar can handle it. So you can see that has a very, very high performance separation of all those objects very, very accurately. Now, why is this a game changing? Because the cost of such a radar is about between 1/5 to 1/10 of the cost of a LiDAR.
Wow.
So now you can imagine a configuration where, okay, we talked about the compute. You have a 360 of cameras. This is way below $1,000. You have a 360s of these imaging radars, which is also way below $1,000. You'll have a single front-facing LiDAR. So front-facing, which is the most critical part of the field of view, you'll have three-way redundancy. You have cameras, this imaging radar, and the LiDAR, somewhere around $1,000. So you can see that altogether, you are getting something which is way below $4,000 in terms of cost. And this is the key to bring the cost level to a point in which we can have a consumer AV. Because today, cost levels of self-driving systems are way above that, order of magnitude above that, which is good enough for powering a robo-taxi, but not for a consumer-level car.
Yeah, I think I'm still waiting for commercial vehicles to take it up, and that will be a big proof point. I mean, that's just general autonomous vehicle driving. I don't think I've seen an L4 commercial vehicle on the road yet myself. And
No.
I think until the time it gets to the point where that's more normal, users are going to be more comfortable with the vehicles. But going back a bit to this EyeQ Ultra chip that you're announcing, I think the big number that astounds me is this 176 TOPS. Now, my audience will be familiar with TOPS, tera operations per second. And when we hear about other autonomous vehicle L4 driving level systems, they're an order of magnitude beyond this, right? So it seems amazing that you guys can claim that you're going to have an L4 equivalent system with only 176 TOPS. I know you're not necessarily going to talk about competing solutions, but I think my question to you is TOPS the right metric in order to understand the competitiveness between different solutions?
I think TOPS is not the right metric, and there are actors that are trying to push TOPS as kind of the new horsepower metric, but it is very misleading. When people talk about TOPS, they really talk about deep learning TOPS, and even with deep learning TOPS, there are all sorts of details that are being omitted. Doesn't include sparsity. Doesn't include the sparsity.
That's one of my questions I'm going to ask you later.
Yeah, it's only convolutional neural networks, or that there are many now new types of architectures of neural networks, and then there's many types of different workloads which are not related to deep learning calculations. And this is one of the strengths of Mobileye, in which, given all those years of experience of building these systems, of computer vision based systems, and also the driving policy, we have the right combination of accelerators and CPUs to bring us to a point which is very efficient. Now, it's not kind of a forward-looking thing. Take, for example, the existing, this car that I just mentioned from Zeekr, the Zeekr brand of Geely. Already, few thousands of vehicles have been shipped already. The functions are going to be OTA'd, over the air update, in the coming months. From basic ADAS to the full level 2 plus, which provides an end-to-end capability of hands-free driving. It's not level 3, level 4. You need the driver behind the steering wheel, but in terms of the capability, it's a full end-to-end hands-free driving. All what we are showing In our unedited videos, this car can do. It has 11 cameras and two EyeQ5 chips. Now, it has only two EyeQ5 chips responsible for the entire perception of 11 cameras in order to create and this is lots and lots of compute. Camera processing, the cameras are 8 megapixel. Each camera is 8 megapixels.
Yep.
So we're talking about lots and lots of data coming in to those two meager two EyeQ5 chips. But then you also have the driving policy, the planning. In a self-driving system, you have sense, you have a plan, and you have act. Right? You have to do the planning. Planning also is a humongous amount of compute if you look at competing solutions. And then you have the control. And we're able to do it on two chips where each of them is 15 tops. So it tells you that tops is really not the right measure. You need to build a system on chip which is sufficiently diverse, and you need to build the right algorithms that are purpose built for the task. And you have silicon vendors that are producing general purpose chips, and then their only recourse to compete is try to define a new metric, which is this TOPS kind of a horsepower metric. But life is much more nuanced than that.
So, I mean, you're saying, two chips for your L2 currently in China, and this is just one big chip, maybe tops per watt. What exactly is the right power for one of these systems that
Uh,
we should be thinking about? Because
so even
this used to be 3,000 watts in the back of the trunk.
yeah, but even watts is misleading. You know, um, Are you talking about only the deep learning engines? Are you talking about the entire SoC? Are you talking about the static power at 125 degrees at the junction temperature? There are so many details that are being omitted when people talk about wattage. Are you talking about the system, the entire system power consumption? This is a better measure, not what is the chip, is the entire system. Mobileye has a system on chips which are behind the windscreen. So we're talking about an automotive grade 125-degree junction temperature behind the windscreen, and performing very, very powerful compute. Systems that are way below 3-4 watts. System, not just the chip.
Wow.
So giving you a number of watts on the EyeQ Ultra, I can give you a number. It's way below 100 watts. Okay, but it's really, without going into all the details about how power consumption is being measured, these numbers are also meaningless. At the end of the day, you need to measure a system level power consumption, and we're building this such that a system level power consumption is system level, not the chip level.
Yep.
System level is below 100 watts.
Oh, wow, that's good. Stick it on a PCI card. That'll be fun. Um, so just to clarify, 125 degrees. So are you saying Fahrenheit or Celsius? Just to be clear.
Celsius.
Okay, 125 Celsius. In
Yes. Yeah,
your
this is the
your
automotive grade. The automotive grade.
automotive grade has to deal with it.
Yeah, that's right.
So that's like Dubai, but in the middle of the engine type
Exactly.
temperatures.
Exactly.
Yeah.
Dubai in the summer. Yes.
So I mean, you mentioned the four types of accelerators that you have before: deep learning, VLIW, CGRA, um,
And
multi-threaded. Yeah,
yeah.
can you be a bit more explicit on what these do and what partnerships you're leveraging for the IP in these?
In terms of IPs, it's mostly the EyeQ Ultra. It's RISC-V CPUs. In the previous generations of EyeQ5, those are MIPS CPUs, and EyeQ Ultra will have 12 CPUs, RISC-V CPUs. So we those are IPs that we license. Our accelerators are cores that we design. This is part of our proprietary, and those cores have been perfected over the past 15 years. So each type of core has seen silicon in previous generations, but is being perfected better and better and better as the technology improves, as architectures of neural networks improve, as our understanding of what kind of algorithms we need. Because but when you talk about algorithms, it's important to make a point where you need to create internal redundancies. So say for example, you have an algorithm that is doing pattern recognition, detecting a car in front, and you try to perfect it as much as you can using data-driven techniques. But then you want to also create another route, another within the same chip, but completely different algorithm. It could be an algorithm that takes a top view by piecing all the cameras together, and from the top view detecting where the vehicles are. It could be an algorithm that is doing pixel level labeling, label every pixel, whether it's a road or not a road. And when something is not a road, then it gives you an indication that maybe you have there either a static or a moving object. You can do a pixel level segmentation for every pixel label what it is. Is it a road? Is it a car? Is it a pedestrian? And so forth. So very different types of algorithms. We have another algorithm called VDAR, which is taking all those 11 cameras and creating a 3D cloud of points, just like a ladder. So
Yep.
a complete depth map, which is another. And then when you have a complete depth map, you can use a completely different type of interpretation, of visual interpretation, because now you have a 3D cloud of points, and now you want to detect cars. So every detection, every perceptual understanding that we want to make from the scene, we do it in multiple ways. And this creates also the need to diversify the type of algorithms, and therefore the type of accelerator cores that supports those algorithms. And this is the need for those four families of accelerators. So it's not just one architecture of acceleration. It's
Yep.
multiple families of and then we have, from each family, you have multiple cores. And I said EyeQ Ultra has 64 accelerators.
So, I mean, this chip is meant to be going sort of kind of in production. We're talking 4 or 5 years out. In the chip space that I usually report on, that is quite early. I'll grant you that. I know automotives have long cycles on this. But I'll pose the same question to you that I posed to the more standard sort of desktop server CPU PC guys I talk to. How confident are you in predicting where the algorithms are going to be that far out, such that you're confident in what you're designing today has the right balance of compute, interconnect, memory for where the algorithms are going to be in 4 or 5 years?
Well, this would have been a pertinent question, say, 5 years ago.
Right.
Today, we're at a point where we know exactly what we need to do in order to build a level 4 system, because we have been building it. I've been building all the components. We have been building the computer vision, and we have cars on the road with our computer vision doing end-to-end autonomous driving. We are building a separate stream of radars and lidars, and we have vehicles on the road using end-to-end autonomous driving with a safety driver now, but autonomous driving without cameras, just radars, lidars. We have been for the 5 years building crowdsourced technologies for building high definition maps, and those maps are part of the perception, right? You're perceiving from sensors, and you have also the high definition map. You localize into the high definition map. All of that. So we have done all of that. So we know exactly what are the algorithms, and this is why we are designing the EyeQ Ultra today and not 3 years ago. We could have done that 3 years ago. We could have done 3 years ago, let's build a humongous chip to support level 4. But then your question 3 years ago, 5 years ago would be very, very relevant. How would you know what kind of algorithms you need in order to support a level 4? Today we know. And this is why we know exactly what is the architecture of our AV on chip, autonomous vehicle on chip. And we took that as building blocks of the EyeQ5. Since EyeQ5 is running now all our autonomous vehicle development, as I said, it's two EyeQ5s today. We have six EyeQ5s for a level 4 capability. Early 2024 as a consumer vehicle. This is with Zeekr. It's going to be announced at the CES. And we have on our Robo-taxi 8 EyeQ5s. So we know exactly what are the algorithms, and therefore the EyeQ Ultra is respectful for all those learnings. We know exactly what are the algorithms and the architectures that we need for a level 4 vehicle.
Given how many companies talk about the rate of progression of machine learning and how the algorithms are changing or are being optimized, that's a pretty substantial, stake in the stand you're putting there. That it's not going to change over that time. Though I guess some of your CGRAs can at least help if there's some
Yeah, these are
configurability
all
in there for sure.
programmable cores, right? It's not an
Yeah,
ASIC. It's all
yeah.
programmable cores.
So I mean, as you said before, the announcement for the Ultra chip, first silicon late 23, production silicon 25. Can you go through where you are right now with the design? Do you have, extensive RTL? It's clear that you're doing simulations. Where exactly do we stand? Because you're 18 months away, which for most chips is a good chunk of the design cycle before first silicon.
Yeah. We are way above the 50% RTL. So in a few months, we should have the 100% RTL and start the back end phase. And we're
Oh, that's
working
good.
with ST Microelectronics. Our partnership with ST Micro goes from 2005, from EyeQ1 till
Wow.
EyeQ Ultra. Yes.
So when other autonomous vehicles systems talk about how much they process, I mean, we've got over the tops argument, but what sort of frames per second or response time is ultra targeting? Because some vendors will say 60 frames per second, some will say 24 frames per second. What's your
Yeah.
opinion there?
Even those numbers are sometimes meaningless because there are many details that are being omitted. At the control level, we are between 50. We support between 50 to 100 hertz,
Yep.
times per second at the control level. In terms of perception, we're working at 18 frames per second. That's sufficient for perception. And then there is in between. There are all sorts of processes that are slower, that are at 9 FPS, which are not critical. They are only for redundancy. And there are processes that are around 24 FPS. So there are many details when you talk about frames per second. It's not one monolithic number.
Sure. And a lot of discussion in the industry is around chip packaging. Is there anything special going on the packaging here with Ultra?
So the packaging technology is the ST's IP,
Okay.
and they have been working on packaging for us on the EyeQ5 and EyeQ4 and EyeQ3 and EyeQ6. It's a legacy, continuing a legacy of building automotive grade packaging for very high performance computing. All our SoCs are at the time of production, a cutting edge high performance compute, and ST is matching that with the right package.
So in 2017, Mobileye was acquired by Intel. And you guys have been part of their financials, and we've seen the numbers for Mobileye go up and up and up over the last few quarters. So congratulations. But
Thank you.
what exactly did the acquisition for Intel bring to Mobileye that perhaps wasn't there previously?
Well, I would say there were three elements. One is manpower. So when we were acquired, we were about 800 employees. Today we are 2,500, but 800 of the 2,500 are coming from Intel.
Okay.
So it's significant because we're not talking about individual people, we're talking about entire teams,
Mhm.
and building teams is difficult, right? So building that 800 people, teams organically would have been very difficult. Second is technologies. The imaging radar that I talked about is Intel teams that have moved to Mobileye. The FMCW LiDAR development using Intel silicon photonics. These are special fabs of Intel. It's also Intel teams that have been moved to Mobileye. So we're talking about technologies that are still outside of Mobileye's organic skills. No, in no dream of mine I could have imagined that Mobileye would develop a lidar or a radar.
Yeah.
Simply, we do not have that skill at all. So this is coming from Intel. In terms of evangelizing our safety models, so we have back in 2017, we developed a safety model called responsibility sensitive safety, RSS, which is today really the backbone of worldwide standardization of how you define this delicate line between safety and utility, because the safest car is a car that doesn't move. If you want to merge into congested traffic, uh, you need to challenge other road users. How you do it in a way that is from a societal point of view considered safe. So we developed that theory, made it transparent, published it, and then through Intel's policy and government groups, we have been evangelizing it. For example, the IEEE, there is an IEEE program called 2846. It's chaired by Intel, which is standardizing these kinds of questions. And RSS is really the starting point for asking those questions. So this is also something that it's a very amplification that we got from Intel. So I think it was a very successful, still is a very successful partnership between Intel and Mobileye.
It's interesting you talk about the safety aspects, because one of my questions later on, I'm going to bring it up now because it's so very relevant to this. It's over the past 10 years, it's been suggested that at some point the technology will be there. We'll have level 4, level 5, and it will work. But the main barrier to adoption will be in the legal systems. Governments aren't ready to, properly produce the laws around these types of technologies. How much thought explicitly do you put into that? In the point where you might be ahead of the legal system, ahead of the governments there.
So this is exactly the question that we asked ourselves back in 2017.
Yeah.
Told ourselves that if we don't do something on the legal front, we will get stuck. And at that time, the common wisdom was mileage driven. So the more mileage you drive without intervention, meaning the safer you are, which to our mind, what was not a sufficient metric. Because when you need to put a machine on the road that should be orders of magnitude safer than a human driver in order to be accepted from a societal point of view. How do you go and validate something like this? So from validating the perceptual system is something that you can wrap your mind around and define it, but how do you go and validate the judgments that this machine
Mm.
makes? It needs to make judgments to merge into traffic. You want to change lane and the traffic is congested, so somebody else needs to slow down in order for you to merge. How do you do that in a way that is not reckless? How do you define what is reckless? How do you define what is dangerous maneuvers? How do you define what is safe maneuvers? And all those, there is lacking of all those definitions. That means because a machine needs to have formal definitions. It cannot make any move just based on heuristics, because you will not be able to defend it in court later when an accident happens. So this is when we started to develop, this formal theory of what it means to drive safely. What are the assumptions that people make when they drive? How can you code it in a formal theory? And what kind of guarantees can you give? Can you give a guarantee, for example, that you'll never cause an accident? And this is exactly what we set out to do in that RSS paper. We wrote that academic. There were two papers in that project. And as I said before, it is today really the basis of all worldwide standardization. And today you see, for example, in Germany, there are laws that enable to remove the driver. For example, you need to homologate. That there are certain steps that you need to do.
Yeah.
The UK Commission, the EU Commission have language that legal language that gives you legal certainty for deploying a autonomous car. And I think US would also at some point have that proper language to create certainty for these kinds of technology. Israel is enacted the law as well, so it's getting there. I think 2022, 2023 for robotaxis is the correct sweet spot in terms of starting to see a deployment of ride hailing, of autonomous ride hailing, and the learnings from it would then propel with the right cost in 2024, 2025 consumer AV.
So on the point on robo-taxis, maybe this is particularly region specific, but I want to posit a possible scenario to you. Robo-taxi goes to pick somebody up, somebody that wouldn't a taxi with a human driver wouldn't necessarily pick up because they either look ill or they're prepared to do damage to the car. If it was a human, they'll just drive off and not accept the fare. With a robo-taxi, that's not part of that situation. So at your level, are you considering these sorts of situations that could be the end point of where your technology is going? Or are you kind of just happy to leave that into the hands of those that are deploying it at scale?
Well, you're talking about vandalism. There could be all sorts of things going on. So robotaxis would also have a teleoperator. So the teleoperator does not, drive the car, but can give instructions to the car in case it gets stuck, in case it doesn't know what to do. It can give it instructions, and it can also solve this issue that you mentioned before. Before you pick up a passenger, the teleoperator has a view from all the cameras of the car, can make a decision: do you want to pick up that passenger or not? But there are more critical issues that could come up, all sorts of violence inside the car cabin. So the cabin is viewed from the teleoperator, has a view of the cabin, sees what's going on, and can deactivate the car if necessary, or call help. I think those issues are issues that you need to think about once you have robotaxis at scale.
Okay.
I'm thinking 2022, 2023, robotaxis not yet at scale. So those issues can wait a bit. But once you really have this at scale, and you need to think about vandalism, you need to find the solutions. But I believe that those solutions will be found.
I've been in a few taxis where we've had to ask the driver to stop because one of my friends has felt unwell after a night out drinking. So hence why I posit that particular question. So on a more personal note, I mean, I'm talking to you as CEO of Mobileye. You are professor with Sachs Chair in Computer Science at the Hebrew University of Jerusalem. You've co-founded other companies in the AI space. And doing my research on you, I hear that you're founding Israel's first bank in 40 years, a digital bank. Do you have enough hours in the day for what you do?
Well, what I do is all around artificial intelligence. Everywhere where I think artificial AI can be transformative, whether it is building autonomous cars, driving assist to save lives, language models, build intelligence, general intelligence, um, disrupt banking as we know it as a digital bank, help people with disabilities, whether they're blind, visually impaired, hearing impairment, dyslexic. AI can help in all those areas, and in each such area, I have a company where my only executive position is at Mobileye, but all those other companies I found or co-found, and I take a chairman position, and then I guide the company. But in terms of an executive position of managing people, it's only Mobileye.
So on the machine learning front, the industry focuses a lot on computer vision, natural language, engines, and those are some of the big ones that have extended into revenue-heavy industries, as I like to call them. But are there any areas of machine learning research you'd like to investigate deeper on, or that the industry or academia hasn't really focused on so much?
Well, I think the new frontier of AI is language, because language gives you gives you a window to intelligence. Because when you have a machine that has very strong pattern recognition capabilities, even say human level or even exceeding human level pattern recognition, you would not say that this machine is intelligent. When you have a machine that can drive autonomously or play chess or play Go or play Minecraft, exceeding human capability, you would not say that this machine is intelligent. But a machine that can master language, this is a window for towards intelligence. And if you can look at what search engines have done to society, what search engines have done is that you have an encyclopedia in your pocket, right? You don't need to remember things. You just simply take out your smartphone and search, and you get an answer to any factual question that you have. Uh, Language, AI in language would bring would bring intelligence into your pocket. So you'll have access to a wise person. It's not just ask a question. Have a conversation with Albert Einstein. Right? Have a conversation, with a philosopher. Have a conversation with any kind of expert that you have in mind. It's all in your pocket, and this unlocks values that are even hard to imagine today. The language frontier opens up the door towards general intelligence. And say 5 years ago, if an AI expert will talk about general intelligence, this expert would be treated with skepticism. Today, I think it's around the corner.
You're talking to a technology journalist who likes getting into details. If something gets that good, that puts me out of a job.
Exactly.
So one last thing one thing to right at the end is something that's very near and dear to me: racing. When will we get level 5 race cars?
I think having a autonomous race car is a much easier problem than having a car that can drive in Paris or New York City.
Well, so in my notes, I said, does that mean that an autonomous driving race should start with fresh algorithms or pre-trained for a given circuit? And so if it's fresh algorithms, you have to do the practice first. Maybe that's a couple of laps with a human, and then you just let it go.
Yeah,
But then what
so
if it crashes?
yeah, well, AI has two streams. One is imitation learning.
Yep,
So yeah, it's data driven. So in the case of a race car, have a number of circuits driven by a human driver, and then the machine generalizes
yep.
and can even do much better than the human driver. And that there's another stream, which is kind of a self play, is
Simulation.
yeah, simulation. And simulation is another big frontier that is happening in AI. Is especially affecting robotics today. The sim to real phase is becoming more and more practical than it used to be. So learning inside a simulator and then launching in the real world is something that is much more realistic today than it used to be in the past.
Excellent. Thank you so much for spending time
Thank
with
you.
me.
Thank you, Ian.
Good luck at CES, and good luck with this new chip and the next couple of years.
Very good. It was a pleasure. Thank you, Ian.
Thanks. Now, many thanks to Amnon and his team for their time. If you've never considered Mobileye before, they are worth checking out. They've got some really interesting silicon designs. And some of their stuff, as you might have guessed, may be in China right now, and it'll be a while before we perhaps see it in this side of the world. But they are demoing, they are trialing, and they have sold 100 million silicon pieces, chips, to date. That will only grow, and it'd be interesting to see how it develops as we go forward. I mean, I really want a level 5 autonomous vehicle. I want to be able to get into a car and just read something on my way to go visit family and friends. And I'd pay for that. I actually did a poll on my Twitter feed a while back saying, how much is autonomous driving to you? And I had like A was 10%, B was 25%, C was 40%, D was 50% plus. And the overwhelming result was only 10% extra. So if Amnon's right and they can get autonomous driving, at least level 4, down to $5,000, that means any vehicle around $50,000. Well, he did say $5,000 for the hardware, then $10,000 for the end product. We're talking about a $50,000-$60,000 car in the future could be fully autonomous. That's going to be cool. Now I just need to check my wallet. What's my minimum specification here? Level 5 autonomous vehicles, or just better yet, let's have autonomous racing, and let's have just so many details in that it'll be an engineer's wet dream, and I'll be sitting in the front row. If you like this content, please don't forget to like and subscribe. We also have now a private Discord server, and if you want access to that, become a Patreon member and it'll instantly add you as long as your emails are linked. You can join the Patreon for as little as $1.50 a month, and it all goes back into helping the channel.